Welcome to the course on Holtek V3 C Compiler. This chapter will take you to understand the basic teaching of the Holtek V3 C Compiler, which will be introduced from the following three topics: Holtek V3 C extended syntax and functions, how to write more optimized programs, common problems and solutions. Holtek V3 C extended syntax and functions. This section introduces 6 extended syntax functions and the use of the IDE 3000 version 3 code generator. These syntax functions includes interrupt service program definition, absolute address variable definition, defining const variable address, defining bit variable, inline assembly language, and specifying function address. Interrupt service program definition, taking the HT66F60A as an example. The project defaults to include HT66F60A.h header file. Double-click the HT66F60A.h file on the left workspace, locate the define_ISR function macro definition, and copy it to the C file. Redefine the interrupt function name and interrupt entry. The entry address is generally a multiple of 4. The specific address can be obtained from the datasheet. Define global variables for interrupts, if used, using a volatile qualifier. If users want to define more than one interrupt entry, modify the interrupt name and entry in the same way. To define the absolute address variable, double-click the HT66F60A.h file on the left workspace. Locate the define_SFR function macro definition and copy it to the C file. Modify the variable type and name and specify its start address. Note that the address should be within the RAM valid range. Hex 180 indicates the ADH address in bank 1. This variable can be used normally in the function. If users want to use var1 in another C file, they should also include HT66F60A.h and define_SFR in the func1.c. It is recommended to define the absolute address variables in the .h file, such as var1.h, so that the C file that uses these variables only requires to include var1.h directly. How to specify const address. First, define an ordinary const variable. Add _attribute _at address hex 100 before the variable to specify its address to the start address hex 100 of ROM. If users want to reference this variable in other C files, declare it using extern const unsigned char array. For the MCUs without extended instructions, such as HT66F50, users need to check this parameter, which is checked by default, to use this function. While for some MCUs without TBHP or with ROM width other than 16 bits cannot use this function. The Holtek V3 C supports defining bit variables. Users can use the bit keyword directly. It is recommended to define the bit variables in the entire program into the same C file, which can be referenced by other C files using extern to save RAM space. The Holtek V3 C inline assembly uses the ASM syntax, where the contents inside the double quotes are assembly statements. If users want to use C-defined functions and global variables, remember to add an underscore character before the old names. When an externally defined variable name is referenced, it should be declared as byte using extern, and for the externally defined function, declared as near. Specify function address. If func2 is to be defined at address hex 100 of ROM, add double underscore attribute double underscore at address hex 100 before the function. Similarly, the interrupt function can also be specified with an address by adding at address hex 110 after the interrupt. Then the func2 is assigned at address hex 100, the interrupt entry at 04 and the interrupt function at address hex 110. The integrated version 3 code generator can be used to generate code faster. Select the version 3 code generator command in the IDE 3000 tools menu to start the version 3 code generator. Most of the languages introduced earlier are here. Take the interrupt function as an example, enter the interrupt function name and the entry address, and select the specified function location. Then click Add. After that, click Gen Code to generate code. Click Copy Code to copy the code to the program. Generate inline assembly code. Enter assembly code in the compile box. Click Gen Code to generate code. Click Copy Code to copy the code into the function. How to write more optimized programs. This section summarizes several optimizations that can save space according to the features of the version 3 C compiler. The first is parameter selection. Double-click Project Test on the left workspace to set parameters and select Build option. Optimize generated code is an optimization parameter which is checked by default. Optimize data memory. If no interrupt nesting occurs, checking this parameter can save RAM. If a large number of const variables are used, check this parameter. If the defined enumeration value does not exceed 256, check this parameter. Click OK to save these settings. Proper variable declarations can save space. In this program, the variable I does not use negative, but is defined as a signed char. This program takes up 25 words to compile. Define I as an unsigned char, which takes up 20 words to compile. In this program I is up to 456, not beyond the int range. Define it as long, which takes up 21 words. Define it as an unsigned int, which takes up 15 words. Using the floating type usually takes up more space. This program uses a floating constant 3.14, which defaults to double type, and takes up 344 words. The precision of float is sufficient, so defining it as float takes up 178 words. This statement is calculated using two floating constants, half multiplied by half. It takes up 172 words. It can also calculated using its result quarter, which takes up 153 words. Try not to define const arrays as local variables. This program defines a local const array. It takes up 29 bytes of RAM to compile. Define it as a global array. It takes up 22 bytes of RAM to compile. Define variables with similar functions into an array. This program defines 4 variables, all of which operate similarly and have regular values. It takes up 136 words to compile. Define them into an array and use loop statements according to their regular operations. It takes up 93 words to compile. The switch branch in this program includes the same code array 0 is equal to 4. It takes up 38 words to compile. Move them all to the end of the branch. The compiling saves for instructions. The statements in this program are very regular. It takes up 359 words to compile. Replace them with a for loop according to their regular operations. It takes up 142 words to compile. Encapsulate frequently used code as a function. These two functions use a piece of code for assigning array. It takes up 90 words to compile. Encapsulate this assignment code as a subfunction for both functions to call. It takes up 52 words to compile. This function is only called by a file. It takes up 220 words to compile. Define it as static. It takes up 185 words to compile. For an MCU without extension instructions, when RAM bank 0 is full, variables need to be defined to other banks. In this example, sum s is defined to bank 1. It takes up 299 words to compile. In the program, sum s is used more frequently than array. If the array definition is changed to bank 1, it takes up 263 words to compile. Avoid using global variable initial values. The program has initially cleared all RAM bank 0, and the initial values are assigned to the global variables. At this point, the initial values are invalid. It takes up 320 words to compile. Remove all initial values. It takes up 283 words to compile. Common problems and solutions. This section introduces several common problems encountered during user development and how to solve them. When this warning occurs, it indicates that the interrupt and the main program share the same function func1, which may result in an error. As seen from the program, ISR_1 and main both call func1. Solution: users can define another function func2 which has the same content with func1. The main program calls func1 and the interrupt calls func2 respectively, so that they does not call the same function. For an MCU without extension instructions, such as HT66F50, when the error information RAM bank 0 overflow is displayed, it indicates that bank 0 space is not enough to allocate variables. In this point, users need to specify the address of less commonly used variables to bank 1 or other banks, such as hex 181. This will allow the compilation to pass. If the local variable I is defined in the main program, there will be no I information in the watch window when debugging. Users can define I as volatile, so its information can be displayed. Note that the local variable defined as volatile takes up more space, so remember to delete it after debugging to save space. The variable var2 is used by both the main program and the interrupt function. Breakpoints cannot be set on line 17 when debugging. It is also skipped when using the single-step command, indicating that the syntax has not been validly compiled, which will cause an error. In this point, users need to define var2 as volatile. This allows breakpoints to be set normally. The program defines a const array, and if the array is modified after compilation in some other way, such as IAP, the result of executing var2 is equal to array3 is still the original value hex ff. There are two methods to modify. One is to define the array as volatile. So that the latest value is retrieved on each read using the lookup table operation. The other is to define the array into another C file using extern. If users want to implement a function of assigning array3, which is hex ff, to the bank 1 address hex 80, the assembly thinking is that mp1l is set to hex 80, mp1h is set to 1, and array3 is assigned to IAR1. But the result is not hex ff, because mp1l and mp1h have been rewritten when IAR1 is equal to array3 is executed. The correct method is to define a variable var2, with an address of hex 180, and then execute var2 is equal to array3. This will assign the correct hex FF to hex 80 in bank 1.